Good morning. Good morning, everyone. Welcome to the second day of the conference. Dr. Ahmed will start the welcome session. Please, Dr. Ahmed, the floor is yours.
Okay, thank you so much. Thank you so much, Dr. Rabia. And good morning to all of you. So it's my pleasure to open the second day of the conference, International Conference on New Computer Science and Engineering Trainings, NCSET 2020, and be part of this conference with my respectable chair, co-chairs, and all of you. I'm delighted to welcome to all of you to NCSET 2020. So thank you so much for accepting our invitation. Firstly, I would like to briefly introduce myself. This is Dr. Ahmed Al-Naggar. I'm Assistant Professor of Computer Science, Faculty of Computers and Artificial Intelligence, Bani Suef University, Egypt. I'm also a co-chair of this conference. Due to COVID-19, this conference has been changed to virtual model. In this sense, I would like to ask all of you to take care of yourself and your families and be safe from this serious infection disease during this pandemic period. We need to pray to Allah to remove this virus worldwide disseminated. For the first time, the NCSET 2020 gathers research specialists from different backgrounds for a great discussion meeting. It is also a special opportunity to build the fruitful relationship between speakers and participants for future collaborations. Therefore, you will see the technical program broadly reflects the common research interests of many units in NCSET 2020. In addition, we are fortunate to have many platinum sponsors to support our conference. So I'd like to thank University of Huddersfield from UK, International Balkan University from North Macedonia, Scientific Innovation Research Group from Egypt, WAS Press, and the Research Synergy Foundation from Indonesia for their great supporting to our conference. In closing, I hope that all of you to enjoy the conference sessions, and I sincerely hope you will reveal that all debates and networking as well. So thank you for your participation. Now, at this stage, it is my pleasure to introduce Professor Joan Liu. She is a professor in the Department of Computer Science, and she is a research group leader of information and system engineering in the Center of High Intelligent Computing. Professor Joan also having previously been team leader in the IT department of a Charlesworth Club Publishing Company. Professor Joan successfully lead and complete 2 research projects in the area of XML database systems and document processing in collaboration with the Bayesian University. Both systems were deployed at the part of company commercial production. Professor Joan, she will present her lecture under the title Mobile Learning Technology Impact and Inside Stories. So welcome, Professor Joan, and you can start your good presentation. Dr. Joan, she's here.
Thank you, Dr. Ahmed. Professor Joan is not yet arrived, so Dr. Ala, just to give the welcome speech to our guests and things. Then until she comes. Thank you so much.
Thank you. Okay, you can start, Dr. Ala.
Yeah, thank you.
Thank you so much.
Hello, everybody. It's my great pleasure to welcome you to our conference room, which comprises two conferences, in fact, the BBSBA 2020 and NCSET 2020. We are very grateful to the World Advanced Science and the organization committees, chairs, co-chairs, keynote speakers, and all attendees of the two conferences. I would like to thank our great keynote speakers, session chairs, and all our speakers and guests. We are delighted to have you with us to participate and share in our meeting. This moment would not happen without your support. My name is Ala Al-Siyufi. It's my pleasure to welcome you, and I extend my appreciation to our keynote speakers, our speakers, and all guests and attendees. This is the second day of the conference where people came from different backgrounds and different research fields. It was planned to get all of us together in one place in Turkey, where we can exchange ideas and enjoy the conference environment and the place. But due to COVID-19, we thanks the video conference technology that let us meet anyway, even virtually. And I am happy to be with you. Have the second day of the conference. I wish it will be successful and successful and wonderful day for all of us. Thank you again, and welcome.
Thank you, Professor Ala, for the welcome speech. Professor Lowe is not yet. I think it's too early in the UK. So I would like to ask Professor Iqbal, can you deliver your speech, keynote speech right now? Professor Iqbal? Professor Iqbal, can you hear me? Hello, Professor Iqbal?
Yeah. I am here.
Okay, great. Good morning.
Good morning.
Just I would like to ask you if you can start the first keynote speech.
No problem.
So,
I can try my level best to the system raising support. Let us just cooperate. Yeah. So before starting, I would like to thank all of you, especially your Dr. Alauddin and Dr. Ahmad and Elgar, for inviting me to be part of this your conference. I really very appreciate your efforts that you are organizing in such a difficult time, and I wish that sometime we will meet, and not virtually but actually, and we will able to deliver the talk. So
yeah, Professor, excuse me for the corruption.
Yes.
Interruption. I will introduce you to the attendees. Thank you. Please let me produce you, okay?
Go ahead, please.
Let me introduce you to the speaker before you begin your talk, inshallah.
Okay. Fine.
You can share your
Hmm?
There is a share screen down. If you
Yeah, I will share. I will share.
Yes, yes. इसको बैक होने के लिए कैसे करें?
Dr. Iqbal,
Yeah.
please stop sharing for your desktop. After I will
Okay.
introduce you, you can share. Okay.
Okay. Okay. Stop sharing. Can I stop sharing this? Stop. नहीं ये screen is paused. It's fine.
Yeah. Okay, now we are going to introduce our great keynote speaker, our first great keynote speaker, Professor Iqbal Ahmed. Thank you for all. And I want to introduce Professor Ahmed to give a short biography about our keynote speaker. He's the ex-chairman of the department, and Dr. Iqbal obtained his PhD in 1994 in agricultural microbiology from Ali Jareh Muslim University, India. He has worked at different places, including research institute, companies, and also universities. He is now at the Al Qura University at Mecca, Saudi Arabia. And in the same time, he is the coordinator of the undergraduate programs of the Faculty of Agriculture in Al Jareh, from 2018. He has supervised 10 PhD and several MSc students completed and conducting many extramural and in the UK collaborative research projects funded by India and the Indian corporation. He edited 11 books and published more than 147 original research articles and 50 book chapters. The research work published has been fairly cited by the scientific committee 12,000 of citations as per Google Scholar. In addition, he is editor-in-chief of the Journal of Pure and Applied Microbiology, and also in many other journals in the editorial board of other journals. He taught many courses, including the courses related to the field of microbiology. His current research interest includes biofilm-based development of PG, PR, and biofertilizers, microbial ecology, metal-microbe interaction, biosorption, novel bioactivity compounds, and anti-infective compounds from the medicinal plants, and also anti-glycation of the natural product studies. Thank you, Doctor. This is a very short bio for our great keynote speaker, Dr. Iqbal. Now you can start.
Okay, thank you, Professor Aladdin, for a very nice introduction, which it is your. I'm very happy to know that you are organizing all these under a very stressed situation, and I found that large number of people are attending your conference and making it very successful. So I will also try to give you a brief talk on a very specific topic. I hope that it will be useful and interesting for all of the attendants. So are you able to see my slides? Hello?
Not yet, Doctor, please. Please share it.
Are you able to see the slides?
Not yet.
Okay.
Could you please share it again?
Now it is visible?
Yes, please. Yes, please go ahead. It's very clear.
It is visible?
Yes.
Okay.
Thank you.
So first of all, I thanks all the members of the organizing committee for inviting me in this very important and international conference, which was known as BBSBA 2020. And I hope that this is going to be very fruitful beginning on a very important topic. So thank you all for your very kind invitation. And with not taking much time, I would like to start that pathogenic biofilm as its control strategy by natural product. But this topic is relevant to the infectious disease management and control. And whatever the information we have so far on this aspect, we will share some of the information which we are working in our laboratory by some of this. Now coming to the next slide, I'm just giving a brief introduction that this Faculty of Agricultural Sciences is a part of Aligarh Muslim University, where Department of Agriculture Microbiology is a small department with 5 faculty members and all working in different domains. And this my department, Agriculture Microbiology, where we have worked in different areas, including on the medicinal plants also. Now coming to the pathogenic biofilm. So what do we mean by the biofilm? Biofilm is nothing but the aggregation of the microbial community in a very specialized manner on any surface, both living and living, and in case in a very complex polysaccharides material or exopolymeric material, which is produced by the microorganism itself. And once the microbes attaches to a surface, whether it is at the living surface or on the non-living surface, and develop the mature biofilm, it is very difficult to eradicate them. So this created much problem both in the food industry as well as in the environmental sciences as well as in the human diseases. So this development resulted into the new domain of the microbial lifestyle understanding, which we can understand based on their behavior, their reproduction style, their gene expression level in the biofilm mode. Normally, what we know is the lifestyle of the microbes in the planktonic cells. I mean, the cells are uh, scattered in the solution or in the suspension and the medium. But here these cells are not scattered. They are as a community, or they are in the adhered form, and they communicate to each other within the biofilm also in a different manner. So the biofilm is defined as the surface associated and highly structured community of microorganisms that are enclosed within a protective extracellular matrix, which is mainly produced by the microorganism itself. So this matrix composition is mainly the exopolysaccharides, proteins, and extracellular DNA, which is produced by the death of the cells in the same matrix or in the same complex. So this is considered to be a very important strategy for the microbial survival, as well as protection strategy against the stress environment. Say, for example, against the toxic substances, against the stress condition, against the antibiotics. So they are protected in that biofilm mode, and they become more and more resistant. So this creates a problem. How to deal with the biofilm associated infection, both in human and animal, as well as in food industry and other situations. Now, this is some of the examples where the microorganisms involved in the biofilm formation, and they are responsible for the infectious diseases. For example, like cystic fibrosis is very common problem of the lung, and which is caused by Pseudomonas aeruginosa and Ascaris sometimes. Sometimes Burkholderia is also associated with this. Now, the dental caries is again another very important area where the Streptococcus mutants involved in the biofilm formation, and sometimes also associated with the fungus. So a large number of diseases are found to be associated with the biofilm mode lifestyle, not on the plankton mode style. Similarly, because these microorganisms are capable of forming the biofilm on the abiotic substances as substrate also, so you will find that in the medical system also, there are a large number of hospital-borne infections associated with the bacteria, which are nosocomial in nature, and they are even associated with the different part of the body, as well as implants, which are devices which is related to infections. So considering all these things, we will find that this
Doctor, you can re-share. You can stop share and reshare.
okay.
Okay, you can stop share and reshare.
Stop sharing. There are some problem that developed here.
I think the problem in the PowerPoint itself. We need to close the PowerPoint and open it once more, because it shows here that it's blank, no slides in it.
There is problem in slide, I think.
If you can just close the PowerPoint and open it again.
Yeah, it is a PowerPoint presentation.
Yeah, I mean, if because it looks like a blank, we can. There's no slides in it, right?
Yeah, that is why I am not getting the.
So if you can just close it and reopen it again. Maybe
Yes,
if you are sharing it from the stack, memory stack or something, and you remove the memory stack, it will not appear. So it has to be copied on the computer itself. So this is my guess.
Okay. Hmm.
Don't save it. Was Rala, do you have the presentation?
Dr. Iqbal?
Yeah, there is some problem is there. I don't know. This slide is not opening. Slide is there.
If you open it from a memory stick and you removed it, it will not. It will appear like this. So is it on your computer, in local computer?
Yeah.
So you may close it without saving. Then you reopen it again, please.
Close without saving, doctor.
I think Dr. Iqbal turned off his computer and restarting the computer because he left the session. Yeah, he's coming back right now. He's joining back. Yes, he's sharing now, so great. Just ask me to unmute. Please unmute yourself, Doctor. Yes, now you're back. Great. We say everything now.
Okay. So now as we're talking about the importance of the biofilm, so that is the impact of the pathogenic biofilm that has been estimated by different agencies and the organizations, that the NIH currently estimates that biofilm account for 80% of the all infection in the body. So this is very important aspect, that 80% of infection in the body is associated with the biofilm mode, not in the planktonic mode, where the drug-resistant bacteria, especially which are the gram-positive or gram-negative, as well as the Candida albicans, all are contributing significantly in the development of this biofilm. So in the case of the pathogenic biofilms. So now there are situations where the more than one microbes can involve in the development of the biofilm, and one is the leading cause of the infection, while other is participating in such a way that it can deteriorate the condition of the host, or it can facilitate the development of the infection process by another microorganism. So such type of interaction of more than sometimes 2 microorganisms involving the mixed infection in a biofilm mode. So that become more difficult how to treat such infection if there are the 2 different groups of the microorganisms involved. Say for example, one is from bacteria and another is from the fungi. So this is again very important task, how to handle this situation. Now difficulty in the treatment of the biofilm infection, as I told you, that this is the increased resistance to antimicrobial resistance, increased opportunity of the gene transfer in bacteria. So the gene transfer we have already investigated that in the biofilm mode, the frequency of transfer is more, and different phenotypic and genotypic expression in the biofilm state as compared to planktonic. So these are the recurrence of the biofilm infection after completion of the course of treatment of the antimicrobial drugs is another major issue, how to deal with this microbial infection. So a large number of antibiotics and antifungal drugs that are used in the chemotherapy, some of these antibiotics are effective in preventing the biofilms, while some are effective only to a certain extent, but there is if there is a mixed biofilm infection, so it will be very difficult how to get rid of the infection, because the nature of microbes involved are different and they are very resistant, sometimes 1,000 times higher resistant develop in the biofilm mode as compared to planktonic mode. So all over the world, there is again rethinking how to exploit the natural products either from the microbes or from the plants, which are especially used in the traditional system of different medicine. And these plants metabolites can be exploited alone or in combination with antimicrobial drugs. So that is why again we are turning back to the solution from the nature for controlling infectious disease also. So what are the steps involved in the biofilm formation? The first step, as I told you, that the prevention of adhesions, the first step in the biofilm formation is the attachment of the microbes on the surface, and if that can be prevented, we can eliminate or prevent the biofilm establishment. So this is one step where we can do something to prevent the infection or prevent the adherence of the microbes on the surface. Now then the disruption of the survival of attachment of biofilms. So when this large number of microbes are attached, then they become a firm attachment, and then they are going to be developed into matured biofilm. So we can prevent the development of mature biofilm by disrupting their communication, cell-to-cell communication within the cell, or by disrupting the polysaccharides, that is the EPS they produced, because the EPS is the major binding force in the biofilm establishment. So if you can prevent the EPS formation, or you can degrade the EPS structure with the help of enzymes and as well as other agents, then it will be possible to control the biofilm at this stage. Now, if we could not achieve this success, and there is already establishment of biofilm has occurred and infection has been established, so what is the option left? A, that we can disrupt this preformed biofilm either by different strategies. One way is, in the case of dental, you know that there are the physical forces are also used to disrupt this, as well as biological forces like use of phage and use of the enzymes and the other things can also be used to disrupt, as well as the natural product which can enter inside the mature biofilm and which can disrupt it somehow, so they can also be utilized in the disruption of the biofilm. So coming to the how the natural products. So here I am taking an example of only one group, that what we very popularly know as the essential oils, and which are the aromatic oily liquids obtained from the plants, different plants, and they are complex in nature, and they have a large number of biological activity already known to these essential oil, and there also certain level of toxicity is also associated with this, but at a low concentration this toxicity is not very high, so we can exploit how the biofilm prevention or eradication can be managed by exploiting the phytocompounds mainly derived from the essential oils. So this is what we, the general information about the chemical composition of the essential oil. Major group is the terpenes and terpenoid, while the aromatic and aliphatic compounds are also attached to this, and they're minor. This is all about this, their structural component, basic information on the essential oil. Now, some of the compounds of the essential oils which had already been exploited in many studies includes the eugenol, then thymol, then menthol, and many others which are derived from the different plants. And their biological activity is already known in many cases. We know that they also have the anti-cancer activity, they have the cardiovascular diseases, anti-atherosclerosis, then antioxidant, antimicrobial. These activities are already been explored about the essential oils. Now, where we are focusing about how the essential oils in the compounds can be utilized to prevent the biofilm. So first thing is that the assessment of antibiofil action of essential oil. So what we can do, that when we talk about the prevention of the essential oils, it means that we are not interested in killing the organism, but we are interested in preventing the microbial virulence, means its attachment and biofilm establishment. But if the biofilm is already formed, then we are interested in the killing the biofilm and eradicating it through this different combination. So one has to first examine that what is the approach of studying the essential oil and compounds for biofilm inhibition. So one has to see what is the toxicity concentration, or what is the MIC and MBC against the test pathogen. Then you have to select the sub-MIC concentrations of these agents, and for studying the biofilm inhibition. And on the microtiter plate and other system, we can also use the glass surface or catheter disc for forming the biofilm on this surface, and then we can analyze with the help of scanning electron microscopy, confocal microscopy, and TEM, and all these evaluation you can do. So this is just an preliminary idea just for the young students who may be interested in this area, that if you are looking for such activity, we can select the different essential oil, first determine their activity against the different organisms which they are going to be used. Say for example, this is one example when we have selected the yeast, that is the Candida albicans and other species of the Candida, and their sensitivity to the number of essential oils and their phytocompounds. So they found that they vary in their activity. And when you determine the minimum inhibitory concentration of essential oil against the fungus, that is the Candida, which is a very notorious and opportunistic pathogen in association with others also. So a large number of Candida albicans and Tropicalis, Courcey, Glabrata, another species has been tested, and you find that their MIC ranges from 1.25 microgram per ml to even 800 microgram. It means that there are variation within the strains as well as within the essential oil. So that has to be taken into consideration before selecting the organism and the essential oil combination. Similarly, if you see the different bacteria, here we have selected the Staphylococcus aureus, Staphylococcus epidermidis, and Streptococcus mutans, and Staphylococcus epidermidis, and we first determine the MIC. Now this is important because when we are going to study the biofilm inhibition, we must know what is the exact MIC and MIC, because only then we can select the sub MIC concentration for the biofilm inhibition. One can also look into the, if you know the toxicity of the oil, which is more efficient in killing the microorganisms, you can test the survival kinetics at higher concentration, and you will find that different oils like T. vulgaris, thymol, eugenol, in comparison with fluconazole and amphotericin B, these are the two antifungal drugs, and you can see that these essential are more rapidly killing the pathogen as compared to drug. This is again with the different microorganisms. We have analyzed their efficacy in terms of killing rate, that they are acting very fast. Now, similarly, when you treat the essential at higher concentration, they damage the cell membrane and structure, and the cellular content is leaked. So we can also determine what is the material leaked by taking the spectra at 260 that give the information with the proteins and DNA leakage, and that will analyze and compared with the antifungal drugs and the essential oils, which is giving a relatively better result in all these tested organisms. Now, as I told you that exopolysaccharides production is a major component of the biofilm. So if any compound inhibiting the important biofilm production role, that is also going to be a very important criteria for selecting it. So EPS production inhibition at sub-MIC concentration, we can test again different fungus, and we'll find that the certain agent especially acting at very good rate. Now this is again data which simply say that essential oil on the biofilm formation in terms of the CFU. Now when we analyze the biofilm formation on the surface of the glass cover slip, isn't it, and treat it with a different concentration of essential oil, you will find that these are the control one. Here is the untreated culture of the Candida albicans, and this is under the light microscopy. This is under the SEM, that is the scanning electron microscopy picture, and you will find that the differences as compared to chlorhexidine, this is also killing and disrupting the cell structure. The thymol as well as thymol treated cells, you will find they are also showing the very good response in inhibiting and damaging cells. If you analyze this structure with the confocal microscopy, how the biofilm inhibition occurred, then you will able to see that the essential oils are also reducing the thickness of the biofilm, which is from the control, it has been reduced to significantly level. So through all these informations, you will find that they actually are responsible for preventing as well as in formation, isn't it? We have again analyzed on the Candida tropicalis, another important strain of the Candida. And you will find that this is the Candida tropicalis biofilm, very good, interesting, and complex matrix with a very important structure you can visualize here, isn't it? But when treated with the thymol, and you will see that there is a disruption of the cells, a dissociation, and the biofilm matrix is disrupted, and there is a cellular damage is also achieve even at a very low concentration, 1.56 microgram and 3.12 microgram. This thymol disrupt the biofilm structure. This is what is the simple on the bacterial cells. What is the impact of these on the bacterial cell biofilms in terms of the percentage of biofilm formation? Again, this is different essential sites inhibiting the biofilm of the S mutant. And here you will find that the bacterial cells, this is the S aureus cells control, while this is the treated with eugenol and other things. So again, the confocal microscopy revealed a significant reduction in the biofilm here also. Again, this is for the S mutant. Another bacteria we use very important in biofilm, which is responsible for the dental caries. So their biofilm is also very significantly inhibited. Here, the S mutant, the 2 strain of S mutant, and the confocal laser microscopy information is there. So all these information which we have obtained indicated that they can be very effectively, they can be used for controlling the biofilm by surface. Now, here we have tried to see how the bacteria and fungus, when they are mixed together, when they form the biofilm, and they can be prevented or not. So encouraging results are also been obtained on this system. So you will find it is a mixed biofilm between the S aureus and Candida. The two cells are very compactly mixed on the surface. The larger one is the Candida cells. This is smaller one, the Staphylococcus aureus. But when the treatment occurs, you will find there is a significant reduction and disorganization of the biofilm structure, and ultimately you will find the eugenol cells. This is again damaging the cells and making very clear impact on the biofilm structure. This is another, you find the Candida albicans with the S mutant, which is also found normally in association with the oral cavity. They are also forming the mixed biofilm, and here you will find that they are more effective against bacteria, and all the bacterial cells are disappeared from here, and you will find that some Candida cells are there. So now these information very precisely indicated that this can be used effectively for controlling the biofilm in different combination. We have tested with the Candida tropicalis with epidermidis, Candida tropicalis with S aureus, Candida tropicalis with other species of the bacterium. Now again, the Candida tropicalis with S aureus, you see the very tropicalis forming the filament here with the S aureus, and on the treatment you will find the desegregation and ultimately the clay. So the similar observation is also on the S aureus. And this is what we have used, how to eradicate the biofilm. So this is the previous slide we showed on the prevention, how we can prevent the biofilm. And this is again about the eradication. If you want to eradicate the biofilm, then you have to use the higher concentration than the MIC. Only then we can study the, means it is 1 into MIC, 2-fold MIC, 4-fold MIC concentration you can treat, and then you can observe their survival pattern in the biofilm state with different bacteria and fungi, and you see the viability data in the biofilm state also indicated that if you can use the higher concentration, they are going to eradicate the biofilm in a mixed biofilm also, not only the single biofilm. So these are some of the very interesting data that one of my students has generated, and although she submitted the thesis, and some of it under publication. And lastly, I would on the basis of these data, I say that Essential Lab have varying capacity to inhibit the growth, biofilm development, and eradication of biofilm. Second conclusion we made, eugenol and thymol showed multiple mode of action to inhibit and eradicate biofilm formed by the test pathogen both in single and mixed state. Third objective conclusion which we can update it interestingly, the different significant synergy of essential ion and compound with antimicrobial drugs reveal their importance in combinational chemotherapy. And further we can take up these study in vivo using the animal model or biofilm model to evaluate the efficacy of these oils and phytocompounds in controlling the biofilm. Now, some of this future area which we can take up from based on the previous this information, we can explore what is the impact of these on the molecular level, that is gene expression of the based on this biofilm associated gene and virulence gene of the bacteria. Then we can exploit the synergistic behavior between the drug and essential oil to assess their efficacy in an animal model. Similarly, we can also exploit these agents in developing a combination with either alone or with the nanoparticles for coating material, and that will be helpful in preventing the infection and adherence also. And the findings may be exploited in developing herbal formulation also for single-use biofilm. So for traditional herbal remedies, they can also make use of this to improve their formulation, at least for treatment of the oral biofilm, which is very common. And thanks for your kind attention. And I also thanks for my present student team, which they contributing directly. But this work which I presented is mainly derived from this student Huma, who completed recently the thesis on this aspect. And she also just published on paper, and some are under publication. And thank you very much for all of you for giving me time and for patience listening. Although there are some disturbance during this presentation, but I hope you find this presentation short but maybe interesting. Thank you very much for your kind cooperation and giving me
time. Thank you, Doctor. And we are delighted for you to be with us, inshallah. And we hope to be with us in the forthcoming conference, inshallah.
Inshallah. Thank you. Inshallah.
Thank you.
Okay,
now,
thank you
if anybody have any question, you can.
If you have any question, please unmute yourself or speak out, or just write on the chat board.
Oh, can I ask a question, Doctor?
Yeah.
Yeah, thank you. Really, this work is very good and very impression for me. And also, I want to ask about if you test some of the peptide-based antibiotics on the biofilm or not?
Yeah, yeah.
And
it is.
And also the second part of the question: how did you expect if we tested something like that on the biofilm information, and if it is will be promising or what?
Yeah, this is very important that peptide molecules and other molecules, they will be having very good effect on the biofilm inhibition. And there are some work already going on in this aspect. People are exploring that how the peptide can be used, isn't it? But if I am sure that if the compounds are available, we can go for it and we can test it for its efficacy first in vitro. Then when you can use the simple animal models, even the C. elegans. So for example, you can nematode, a small nematode that can be used for creating the infection with Pseudomonas aeruginosa and then testing the peptides for its efficacy in controlling the infection. So I'm sure that some of the peptide will be active and they may be tested. Number one. The second part is that a biofilm is the very, very important emerging areas which have much relevance in infection control, because most of the antibiotics have become non-effective if the bacteria develop biofilms. So we have to develop the suitable antibiofilm agent which can be used, if not alone, then in combination with the antibiotics, so that the persistence or recurrence of the infection must be prevented. So that is very important. Second is the biofilm agent can be used for as a coating material. When many people have developed the nanoparticle based anti-biofilm agent, and they use for coating purposes on the medical like catheter tubes and other surfaces, even in the food industry, to prevent the adherence. So if you can prevent the adherence, that is going to prevent the biofilm establishment. So of course, the biofilm, anti-biofilm agent is going to be a very important area, not only in the medical, but also in food industry as well as in the environment.
Yes. Now I really, actually, we have isolated many of the peptide-based antimicrobial peptides, and and now if you I understood that you said that it will promising to be work on the biofilm formation. But the second challenge, I think, the second challenge is the funding of this research, because as you know, the isolation of a peptide, relating the isolation of gene and gene expression of this peptide, and then purification or maybe used as crude extract in the media of the producing organism, and in addition, the funding of some of these research is very challenging for us to make some, because something like that, because this production and purification is very costly.
Yeah, that is a problem, major problem there when we talk about the peptides. So either we have to go for the synthetic peptide or peptide already available in the market, or in the public domain, to screen them. But they again, if they screen them, if you find something, the patent will go to the other side. So if there is some novel peptide which we can isolate from a producing organism, then it may be useful. So although many, if you isolate an organism which is producing promising activity, and we know that the product is a peptide, then we can work on it, and then we can submit the project and we can get the funding. But initial data must be provided that we have a strain and that is giving the promising result. If this background, if we submit the proposal, that is not a very big problem. But the initial data must be convincing to the funding agency that yes, we have the organism, and we are going to have good, very novel peptides which will be going to be useful.
Thank you, Doctor. And it will be my pleasure to contact, to make a personal contact with you, inshallah, after our conference pass.
Okay, we will discuss, inshallah. We will discuss.
Questions on the board from the audience. So one of the questions, where is the use of biofilm? This is one question from Dr. Sakumar. Can you hear me, Doctor?
Doctor, you can copy and paste again for the Professor Iqbal.
It says where is the use of biofilm?
Use
of biofilm, yes.
Yeah, biofilm. See, I have talked about only the pathogenic biofilms. Pathogenic biofilm means the biofilm which is formed by the disease-causing microorganism. Now, another area where I'm working already is the biofilm which is formed by the useful microorganism. And that biofilm is useful microorganism in association with plants, in association with other sources in soil as well as in the gut microflora here and there. So it depends upon the nature of microorganisms, because you know that most of the biotransformation process in the environment is going through the useful microorganism which is not existing in planktonic mode, but which is existing in the biofilm mode. So PGPR is one area where I am working, and we have a good number of publications, and we are exploring how the microbial plant root microbiome, which form the biofilm on the surface of the root, can help into the plant growth promotion, can provide stress tolerance to the plant, and can prevent the toxicity of the plant from adverse condition or stress condition. So we have a large number of the useful application also of the biofilm depending upon the nature of microorganisms.
Okay, thank you so much. There is another question saying from Professor Haider, can COVID-19 virus from biofilms? Would like Haider to elaborate?
COVID-19, doctor. COVID-19.
Yeah, it is very important. I was supposed to submit a project on it, but since I already have the 2 international projects, the third I cannot submit. That there is a speculation. There is a speculation that in the COVID-19, the death is mainly due to the primary infection caused by the virus, but the condition which is deteriorated very fast is suspected to be the biofilm forming microorganisms which is already either residing in the lung or which is reaching in the lung. So there is an important role in the disease management, even in the COVID, that need to be explored, because we cannot take the sample from the lung and from the patient, all these things. So the things are not underway, but there is an important role. The secondary infection by the bacteria which is forming biofilm in the lung is going to be very, very serious in deteriorating the COVID patient. So this is many scientists and microbiologists from Europe and UK and other countries, they have stressed the need for studying the microbiome or bioforming microbiome from the patient lungs. Unfortunately, we don't have the sample to analyze it at present.
Okay, there is another question saying how to preserve biofilms for future experiment.
No, biofilm preservation is not important. Biofilm microorganism is preservation important. If you preserve the microorganism, then in the whenever there is a situation, you can apply the microorganism, it will form the biofilm.
Okay. There is another question. What about the biosafety of biofilm?
The biosafety that depends upon the nature of organism again. If you are working on the pathogenic biofilms, so you have to follow the same rule as the rule for dealing with the pathogenic microorganisms. If you're using for the useful non-pathogenic microorganisms, so there is no problem with the safety.
Okay, great. There is one last question is, I would like to ask, this is from Dr. Maria. I would like to ask you if you are investigating anti-quorum sensing too.
Yeah.
Okay.
Many compounds, you know that in the biofilm mode, if it is bacteria, they also communicate with each other, both in biofilm form as well in the non-biofilm form, means in the planktonic state as well as in the non-planktonic state, there is a cell-to-cell signaling going on. So many times you will find that anti-quorum sensing compound also effective against biofilm establishment, because they block the cell-to-cell communication within the biofilm. So sometimes they are also effective as a quorum sensing inhibitor, or they can prevent the, or at least they can weaken the biofilm.
Great. This was the last question. Thank you so much. Thank you so much for your time and nice presentation. up to you, Dr. Ala.
Thank you, Doctor. Thank you very much for your interesting presentation and for sharing your knowledge, your great knowledge with us. And inshallah, we are hoping for the future cooperation with us, inshallah.
Inshallah, inshallah. It's my pleasure. It's my pleasure. Thank you, all of you for listening.
Now, Dr. Rabia, you have the mic with the Professor Juan. Yeah.
Thank you so much. Now, Professor Juan Lu with us. So she is the next speaker. She is the next key speaker. Just let me introduce her first. Okay. Professor Juan Lu is in the Department of Computer Science, and she is in the research group, is a research group leader of Information and System Engineering, ISE, and the Center of High Intelligent Computing, CHIC, having previously been the team leader in the IT department of the Charles Worth Group publishing company. She successfully led and completed 2 research projects in the area of XML database systems and document processing in collaboration with Young University. Both systems were developed as part of a company commercial product. Professor Lu also published 7 academic books and more than 200 peer-reviewed academic papers. Her research publications have a large number of reads and large number of citations by the international colleagues, according to the incomplete statistics from the ResearchGate. Professor Lu has acted as the founder and the program chair for the International XML Technology Workshop for 11 years, and serves as a chair of various international conferences. She is the founder and editor-in-chief of International Journal of Information Retrieval Research, and she serves as the BCS examiner of database and advanced database management system. And she is an FHEA. She has been the UH principal investigator for recent EU interdisciplinary computer science and sociology projects, with different projects like Duet and Dunet, and some along with other more combination of companies, almost 15 from 15 countries. So it's my pleasure to welcome you, Professor Lu, and we missed you at the first session, but yeah, I'm very happy to have you now. So the mic is yours, and you can share your slides, please.
Thank you, Chair. So I'm very happy to have this good opportunity to talk with people, to meet all the people here, because this special situation, the virus cannot stop us to come together. Share conference to gather all the researchers together in this special issue, special sessions. So today, I'm going to introduce a topic that means we are going to introduce our pedagogical societies and into our real learning application. The topic is related to mobile learning technology. And then this technology has been developed for nearly 20 years. Initially was in the American company. The American company, they developed some small device, electronic device. You have to use this device to link to the specific equipment. And then if learner use this technology, and they can interactively talk from the trainers. However, the problem with this is not linked to the network. So they feel very difficult. They are largely rely on this technology, and they are largely rely on this device. If device got malfunctions, and all the class will be disaster. So this is previous generations of learning systems. And then with this platform in the European universities, and then we think we should develop our technology, and we should not rely on the main hardware. We should rely on both environment and network, and also advanced internet technology as well. This is why we come to this project, and project was successfully sponsored by the European Union for continuously for almost 4 recent fundings. So first, the concept for this talk is inspiration, understanding, and knowledge harvesting. So you come to the university or you come to any learning environment. First, you want to know what do I want to learn, how to learn it, and am I interested in this? So that is, and in the end, you want to get your outcome. So that is understanding and knowledge harvesting. And then this is my affiliation. I'm in the Department of Computer Science, University of Huddersfield. The Huddersfield is located in the West Yorkshire of England, but currently is very rainy. So if you have a chance, come to the England, I would like to invite you to give us a talk, especially for your very interesting research outcome.
Certainly will do.
So for today's interview, for today's overview, under the trend of mobile learning. Secondly, we move to the technology. Then finally, where we are. So trend for mobile learning is not so it's not very it's not very slow. It is very fast. You can see from the 2000, the number is quite slow, quite small, and then gradually become very, very large numbers to the 2018, and 2019 and 2020 is even more. And then we need to think about the situations, difficult situations and challenges. What situations currently? The situation for the all universities are very, very difficult to find out effective learning, because the students paid huge tuitions. They want to get some return from their learning. So that is a challenge to the both professors, students, lecturers, and other administrations. That means effective learning involved anyone in the university. Trainers are struggling to find a solution for what is the best way to deliver the knowledge to the learner. Because the trainer, they thought they have taught students good enough. However, the students are not interested in. This is a situation for every classrooms. And then another one, we have large number of students from all over the world. And then even they paid heavily tuition fees. They spending more because they don't want to get very, very poor results. This is international students' expectation. And then currently, you know, this COVID-19, everyone have to go to the online learning. Everyone have to leave the classroom, leave the lab. They have to stay far away from their normal learning communities. So this is called social distance. And then social distance to keep students away from the teachers, lecturers, professors, face-to-face, or just very close supervision. So close tutorials. So what's happened is, and then they said students become just every day, just become addicted on the computer. And then the teachers become presenter, like TV presenters. So that is really very, very challenging for all the learners. And then another question introduced, more smartphones. Smartphones becomes necessity for young generations. So we need to use this smartphone technology to encourage students to engage their learning, to engage their engage their communications with all the instructors. So this is smartphones. And previously, students cannot use smartphones in classroom, but now you can't stop them. They have to use a smartphone in the classroom. So changes are needed. First, we need to first satisfy our learners, and the driving force, of course, is from the learner and the teachers and the instructors. Learning outcome, effective deliveries, and then what should be next? Methodology to the technology, because always methodology driven by the technology. Technology developing very fast, and then everywhere is advanced technology. However, the methodology should be improved, updated. The traditional learning and teaching is significantly inefficient. So, the impact. The impact on the traditional classroom, student-centered learning. that is very obvious. Problems everywhere. Students just sleeping and daydreaming, and they cannot engage 100%. And then we need to introduce new activities. For example, collaboration, collaborative learning, remote teaching, problem-based learning, and opinion-based learning flexibility. So this is a new method should be introduced into classrooms, not just for the online learning. And then technology should be introduced as well. And the devices, and the environment, and digital games, and also operating systems. Operating systems involved all the current popular operating systems. And then the data information retrievals, natural language processing, and the machine learning, all this to deal with the learning data to analyze. And then the devices, response technologies. Now, we introduce these concepts. This concept is combinations of technology and pedagogical methodology scenarios. And then technology all above linked to the current latest environment, cloud systems, wireless systems, and internet and devices. And then the pedagogical technology is.
Excuse me, Professor Lo, would you please share the slides? It's not shared.
Pardon?
Would you please share the slides?
Yes, I'm sharing the slides.
It is black.
Blurred.
Yeah, it's black. It's nothing on the board.
Okay, I will check.
Okay, thank you.
Oh, sorry. Screen share. Can you see it?
Yes, now can we see? Now we can see it. Thank you.
Can you see previous one?
Yes, yes, it is moving. Yes, everything is okay now.
Okay, so we carry on.
Thank you.
Okay, thank you. How many slides are black?
Now it's 2 slides or something. It's not
okay.
that.
Not much. Okay.
Yeah.
All right. So this one, this one is our scenarios for the whole framework, and then framework need to combine with the technology including computing science and electronic technologies as well, because we need to use mobile device. We need communication very quickly. We need to get rid of delays of response, and then we need to use different network. So that is technology. And then the next one is very simple. We need to get information, and we need to get information. We need to store information from the teachers and from the learners' response replies, and then we need to automatically store it and then reuse it for analyze for future research. And also we involved the scientists from psychology, and because psychology can analyze, psychologists can analyze data to analyze students' behavior, learning behaviors, and also teaching behaviors as well. So this is so we finished this whole systems. We deploy we used it in the different disciplines, in engineering, in economics, in law. And then we got students. We got students from Europe, and then we used the whole framework including the information resources, service providers, and then of course including the 3G, 4G, 5G, because we need faster communication. And guys, we go as long as the internet communicate and linked for the, and then we back to the trend of mobile technology learning, and from this data, we find mobile technology from 2002 is almost 7, very, very small, and then until 2020, that is about 4,478 applications. So that is very, very promising areas for mobile smartphone technology, because technology always advanced than the methodology. So this is an example. So many subjects are using this mobile technology in their learning: biology, astronomy, and history, and medicine, math. Language, class teaching, and training. Currently, class teaching and training is the most popular one. And the devices are varied, and not all of them linked to the smartphones, because for commercial company, they think about their market. They don't use smartphone to link to their devices. They just use their small gadget. And then basically we introducing response technology in the framework. Response technology in theory is very straightforward. We need a response, we need a server, we need a network, we need a trigger and a receiver, all controlled. Trigger all controlled by the instructors, and receivers all controlled by the learners. So also trigger can be a receiver as well, because if students may propose a question to the teachers, and the teacher has to accept it. So the challenges, technology here, theory is here, history is here, and then we need to think about what challenges to us. The challenge is interface first, because any application has to be used by the individuals. So interface must be very friendly, simple, and interactive. You can't put too many IT stuff, and no one spend the time to learn basic IT operations. Relationship, conversational and open. So making your relationship very, very friendly and open between these users. And operations must be minimal clicks or press the buttons on mobile device, because all the users are expecting the results. They are not expecting too many operations and then can't remember. So next one is services. Services are very challenging because large data, especially streaming data from a network, so it should be fast and reliable for multiple reasons and simultaneously, and multiple organizations, sometimes multiple countries. So impact of COVID-19, because platform has been changed. People use Skype, Zoom, and TeamViews, all these platforms. How can you increase or introduce your scenarios, technologies, and pedagogical concepts into this new environment and into this popular environment? So we developed first generation. We call student response system. It's quite simple and very interactive. However, and then the graphic effects is very, very good. However, this technology still got some problems. What is missing? We miss missed engagement, efficient delivery. And then because we can't measure how many students are interested in the topics or in the teaching, it's difficult. And then students just press button, but they can't respond. They can't tell the teacher what they are thinking. So in this case, we need a new methodology to come to the conversation and to come to the framework. So we introduce smart learning. Smart learning model. First, we need to think about, for any environment, we have to think about brainstorm, engagement, behaviors, and then how to get this interactive with each other. So we need to have social sharing, games, and interactive response, assessment, and then all this data linked to the backend technology. So activity linked to the technology. And then we move to simple model, because this is very, very complicated, difficult to remember, so many components. And here, just summarize very, very simple model. The simple model with inspiration started and with understanding and move to the outcome. So this process is very, very abstracted for the normal learning process. And then to the experiments. And then first thing, we introduce games for inspiration, and the game students play the games, and when the games, they got reward. And once they got an award, and they feel very, very inspired. And then they move to understanding. And then we, after the games inspirations, and then we send out the questions, and then students responded the questions for their basic understanding, and then we give lectures. And after lectures, and then we give them response question as well. And then they feel really, really interested in this methods. And then when they come to the exam, and then they feel very confident, because they have learned, they have understood, and then they can answer their question. So the outcome is quite promising. Only 2 students, they are not very promising, but most of them are doing extremely well. So the system we used for the physics, and then the physics, math can be used straight away, and also language learning. And then, but we still need to think about, we have large number of international students that come from all over the world. And then when they finish their learning, they'll go back to their countries. And also we have to link to our collaborators in other countries. So the system included multilinguals. The multilingual we used in European countries, in Arabic countries. For example, Arabic, and then the Arabic users, they are very, very interested, because they can understand the languages, and they used in the, not just used in the classrooms, and also in the UAE government, they use it for getting information and to help to make decisions. And then the whole system is into the different formats. and then internet connected with smartphone technologies and outcomes, questions, assessment outcomes. And then students are in the classroom, students are very, very interested when they get their results, and then they find it very exciting because they did very well. And then case studies in the Europe universities, and then the results are very, very interesting. And then for the industry as well, the training was in the 7 countries, and also another is from the from Eastern Europe. This is from Western Europe, and this is from Eastern Europe, and also from in India as well. University, some university in India, and then we UAE, and we have other countries as well. So, in summary, the popularity of mobile learning provides new dimensions to today's learning communities. Diversity of devices is against the traditional single classroom-based learning, and the dynamic learning environment is against the static learning cultures. Student-centered learning is against traditional lecture-dominant style. So this is summary. And then results are very promising. Most risk students in the first year, because traditionally some first year students is very, very challenging for the new environment in the university. Some of them couldn't cope with and dropped it. But now with this new technology introduced in classrooms last year, and about 100 students, none of them got dropped, and they are progressed very well. And then in conclusion, the advanced technology and advanced methodology and equals excellent outcome. And then, so in summary, in the end, inspiration, understanding, and knowledge harvesting with the advanced technology can improve our learning environment. So this is resources. And then these are previous and recent researchers in our groups. All the work contributed by them, they are excellent. They come from all over the world. 90% of students are international students. They are excellent. So this is my talk. Thank you.
Thank you, Professor Low, for your informative presentation. We're glad to have you with us. Now I'll turn to the audience. If somebody has a question, please go ahead. You may write your question, or just unmute yourself when you speak out, please.
Yeah. Question.
There is one question on the chat board. Can you read it? Were you able to read it, Doctor?
Chat 4.
Yeah, in the chat 4.
I need to go back to the share
screen. Okay. I can read it for you.
Oh, which one? Oh, chat 4, yeah?
Yes. And the chat. Dr. Sheikh, he is saying, thank you, Professor Juan, for your interesting presentation. Could you please recommend any practical or tutorial teaching model that can enhance the engagement of the students?
Yeah, that's a very good question, and also not very easy questions. Because the tutorial, normally tutorial is very close working with students, yeah. But for these new situations, we have to use some devices. For some system, for example, we can use the Microsoft TeamViewer, and then we can use Zooms like this, and then we can post questions, and we can organize a group individual, group, and sometimes at this moment, I have to tell my students, I can talk to you, group, individual, day and night, anytime. So that is our new situations. We have a few weeks ago, we had a group teaching, group students about 10, and just a small tutorials. And then we just talk to them, what's their difficult, and then what's their problems for learning. And they just tell me one by one. And then very quickly, 1 hour is gone. So we have to say, if we use slides to give group people use new platform like Zoom or TeamView, and then students just like another lecture. So we have to think about if tutorial you can't face-to-face, you can face-to-face, you can't show students how to do it, and then you have to give more details support to the students. So that means the lecture should have some more workload. So that is the situation in the future as well, if you want to please your students. Am I answering your question?
Okay, great. Yes, there is another question. I don't know, Dr. Sheikh didn't reply. So there is another question from Professor Hikmat. Do you face problems with first year students?
Yes,
no,
yes, that is really very. I'm teaching electronic engineering students for computer programming in the first year. And then first year, most students come from different background. They have no experience in programming. So they feel really very struggling to get the concepts. And then we just use a game to let them to play. And we develop a game let them to play the syntax and play the code. And then after that, we ask them to test it in the platform. And when they have done the test, they find the results, they feel very exciting. Say, oh, it works. And then next one, we use response technology and to ask them, get them feedback. And then when they find they answer the question properly, and then they feel very excited. They are satisfied because they learned. If we don't give them this new technology, these concepts, if we don't introduce these new scenarios in the classroom, normally students after class, they just do something else because they feel very, very difficult to get this imagination and abstract thinking, because programming is very, very difficult for someone who has poor imaginations. So, but however, if you introduce different way to stimulate their interest in, and then they will find that they have something achieved. So the sense of achievement makes them feel really very, very interested in the study, in the learning.
Right.
Am I answering your question?
I think so. There's two questions.
Yes.
There is two more questions.
Yes, self-commitment is really, really important for first-year students.
Okay.
Because some students, they come from college, and then in college, they are used to get pushed by their teachers, and then they just call sir, mom, this, always this. However, come to the university, normally is independent learning. They won't. No one push you. It's your learning, your driver. Wow. But if you introduce smart learning systems, and then it seems their learning get measured. If they find that their learning can be measured, they become motivated. When they're motivated, they always come. For example, we give students every week 1 lecture, 1 tutorials. And the lecture, we give them lecture questions, start 1 and end 1. And for the tutorials, and each tutorials, before it started, and the questions on the screen. And then students come to immediately log in and answer the question. And then they start to do their tutorials. And when they finish their practical work, and then they get answers, they find that is really, really useful because they can use their learning effectively into their practical immediately. So this is called engagement. Student engagement is very important for the self-commitment. If they don't engage, they never gets committed. So smart learning framework is encourage students to build up their confidence through the engagement.
Okay. There are 3 questions from the audience. The first one from Dr. Isa. He is saying, great presentation, Dr. Lowe. However, how did you tackle or address the problem of self-commitment to smart learning from the student side? So he's talking about the self-commitment to smart learning from a student side, student perspective.
Self-committed learning, I think students need stimulation and encouragement and engagement and also achievements. If they find that they haven't got any achievements for this module, for this topic, they are not interested in any learning in the class, and then they will think something else. So first you need to encourage them to stimulating, interesting. That is why we introduce the game to the students. However, this is very argued by the debate. This is debatable by the community because students play the game may particularly on the game and may lose their time. However, if they play the game related to that topic, that will encourage them to inspire them to the topical areas. Because the game always played to get some reward. They got a reward, they got a sense of achievements. So this is inspiration. And then only inspiration is not enough. You need to measure their understanding and measure how to measure their understanding. And then you need to, after game, you need to give them some little bit of serious, in-depth questions, not super learning, not superficial learning. So in-depth learning, the further questions to them, and then they find it will stretch them, stretch their capabilities. And then some strong students find the stretch capabilities really very, very useful. And then so they are more interesting, more engagement. So 3 keywords. One is stimulating, another is measurement, and engagement. So 3 keywords are very important for encourage students to come to self-commitment. And another thing is, in the end, the outcome is not just their results, outcome is their confidence. If they have confidence, they will be very, very happy. And most of my students, when the first year finished and second year, that was really very, very easy. And some of them move to the final year, some of them move master degree, and some of them are doing PhD, and a few of them become lecturers in the university. So because they are interested, and even now they still are very interested in your class because it's new. This is new methods, new technologies. Okay. And then so for research, this is a very interesting topic because research for computing science, yeah, we always link to some models, data, and all this kind of mathematics and predictions. So all this data are sufficient for you to do research in different directions. For example, behavior science, behavior science, and psychology, pedagogies, and also technology always got plenty rooms to do research because technology is not perfect, always not perfect. We need to, for example, at the beginning, we got 5 seconds delayed for the response, which was feel really very, however, one of my researchers, he's expert in the communications. He sorted out very quickly and then no responses very quickly, no any delay. And then another for the network, for example, cloud systems. And we always think, people think of securities, people think if a system broke down or something. And this researcher, PhD researcher, he's really very good at networks. He said we can have backups, we don't have to always use house developing systems. We can use computer packages, we can use other things as long as our data is safe and backup. So another thing for analyze computing science, you got too much data to analyze. You got plenty technology. For example, natural language processing, you can analyze in details students these variables, how these variables defined for different learning. But learning always developing in a different different directions. Maybe this time in one direction instead we learn is possible. Is optimistic learning. Another way, so no, we are learning is because we are just pressed by the pressure, workload. So all of this is for you to learn. And another delivery. When you analyze the data, you may find the teacher's delivery is not good enough. And then, so all of them, you can find there's plenty of space for computing science to explore. And we have physics, we have social science, and all involved because they just want to get data to analyze what's happening in their subject area. And how to analyze computing science. And they use smart learning systems, and they use machine learning technologies, deep learning, all they can go deeper and deeper and deeper to details to get. This is research plenty of space. Last year I went to India and visited a few universities. They are really excellent, and also the researchers are very smart, all doing deep learning system, and they use the systems. We got data, that's very good. Sometimes it's difficult to collect the data. We know the problem there, but not concrete evidence. So, am I answering your question?
I believe he already thanked you for that. There is one more question, and this is the last question. Any recommendation about the online assessment tool for practical oriented courses, for example, computer programming, computer network courses? So is there any online assessment tool for that?
Excuse me, can you repeat the question?
Any recommendation about online assessment tool for practical oriented courses, like computer programming, for example?
Online assessment for the computer programming, I think I have collaboration with my colleagues in another universities. We developed one system is called anti-plagiarism for the code writing. However, this is very debatable, and then because sometimes currently system is very programming system is very optimized. It's very easy to use for the. It's difficult to say which code is. If you use the other people's code, of course, if you acknowledge it, put references, that is not plagiarism, unless you do not acknowledge them. If you are doing advanced research, you always use someone's systems. For the program teaching, currently I haven't seen any commercial systems, but we can use some like e-learning platforms. They have some different format for the testing. For example, they got text, for example, they got text like true or false. They give you questions kind of for concepts. This code, this syntax is good or not, good or bad. So this can be some generic questions. And another one is you can use short questions, for example. Give students some error code. Next student identify which errors, and then, however, they are not very accurate to set which one is correct, which one not correct. But in the teaching, assessment is really very difficult for students. Another one in MIT. MIT developed systems for learning code. And their systems give you some use graphic compilations. Said this one is for the control system, control statements, and this one probably is for the procedure statement. This one is for object statements. They give you this few statements, and then you put your statements, and if your code is tested, they pass your model. However, this is very smart system, it's very good system for measure students' learning, but still not very debatable because it's not very accurate. How can measure students guessing? Because the big problem for student learning is guessing. Because guessing is really very dangerous for students. If they guess right, don't mean they can do a good job in the future. They can get employed. They can't use guessing techniques or guessing skills in the industry, get employment. That is good danger. So that is challenge. So next probably we can do some project together. It's your challenge.
Sure.
Okay. It's good.
Thank you so much, Professor Loh, for your presentation and being with us. We are glad to have you. And now we'll move to the break for 30 minutes of break, starting from now. We'll come back. Thank you so much. Thank you so much. We'll see you. I will be in touch just after the conference. And somebody is asking for the slides as well. So if you don't mind, I can share it. I can share it with them.
Yeah. Okay. Definitely keep in touch. All the colleagues, I'm really very welcome to everyone to come to visit us as visiting scholars and or as researchers or as PhDs. Just come look at it. This is not complete. There are our researchers excellent. Some of them become professors. Some of them work in Oxford University and in Edinburgh, all over the world. In the Manchester universities, all over the world.
Great, that's great. Thank you so much. Thank you so much. Thank you our attendee for being with us all of this time. We'll take a break for half an hour and come back. Thank you so much. We'll see you on that. The system will be online, so if you want to stay, just stay. Thank you.
Bye.
Thank you. Welcome back, everyone. Thank you for waiting. We'll start our next session with the, actually this session has 4 speakers. The first speaker of this session is Dr. Isa Al-Rashidi. He is an assistant professor at the University of Hayab. He will be sharing with us his work entitled Introducing Fog Computing Technology to an Internet of Things Cloud-Based Anti-Theft Vehicle Solution. So I believe Dr. Isa, he is here.
Yes, Dr. Rabi.
Yes.
Yes.
You can start, please.
Yes, sure.
Great.
So,
yeah, we can see your presentation now.
Assalamu alaikum. Hi, everyone. Can you hear my voice, Dr.
Yes,
Rabi?
Yes, doctor.
Okay. First of all, I would like to thank the organizing committee of the International Conference on New Computer Science Engineering Trends 2020. And special thanks to Dr. Rabi, Professor Dr. Qusum, Professor Ahmed Al-Najjar. And it's a great experience for me to participate in this e-conference due to COVID-19. May Allah protect us and our beloved ones. Having said that, my name is Isa Rashidi, and I'm assistant professor at School of Computer Science and Engineering at Hayab University. And I'm interested in artificial intelligence technologies, big data, Internet of Things, smart buildings, smart cities, and agriculture domain. Also, I'm not forgetting the financial and business sectors. What I'm going to present today is the initial result of a recent study that we have worked on, and it's undergoing project. My topic is, as you can see, is introducing fog computing technology to an Internet of Things, cloud-based anti-theft vehicle solutions. My outlines for this presentation, I will give a background and show you the research effort in smart vehicle anti-theft systems. I will show you our methodology, and then I will talk about the framework that we have developed so far, and I will show you the initial outcomes, and we will discuss the advantages and disadvantages of integrating cloud, fog, and IoT technologies within the smart anti-theft solutions. And then I will show you the future work for this work. As we all know that many of us have cars, and if not have been like stolen, they have been undergoing cases of car thefts in many countries and in our country as well. So how does the technology solve this issue of the stolen cars? If I'm an owner of a car or a vehicle, how can I prevent or at least get back my car in case of if it's stolen? So what we did an initial review from 2013 until 2019. We investigated these studies, and the references will be shown at the end of the presentation. What we found is that most of the theft systems or anti-theft systems, they mainly use the GSM technology alongside with the GPS technology. So as you can see, until now, 2019, they started to introduce the cloud computing technology to these technologies. What about the Internet of Things? They have recently, in 2007, they adopted IoT. And by looking at all of these, none of them have adopted the fog computing technology. So just to highlight what do we mean by Internet of Things, cloud computing, and fog computing, we will go back to the definitions as shown here in this slide. Cloud computing is a model for enabling a convenient on-demand network access pool of configurable computing resources. That is network service, storage, application, and services that can be rapidly provisioned and released with minimal management effort for service provider interaction. So as we can see, the cloud computing, it acts as a back end, and it acts as a back end to the data. And the Internet of Things is the technology that connects the whole intelligent entities within the specific networks. That is the internet. It compromises all types of computer technologies, both hardware and software. Its main targets is development of application for devices to enable controls and monitoring vertical domain. The Internet of Things to connectivity incorporates people, machine, and tools and locations to achieve different intelligent functions. So mainly the cloud computing and the Internet of Things are two different things. The cloud will act as a back end in our case, and the Internet of Things devices will act in the front end. So what lay in between these two layers is the fog computing. Fog computing is a highly virtualized platform that provides compute storage and network services between the end devices. In our case, is the cloud computing, and the edge network. In our case, is the Internet of Things. Having said that, we are moving to the adopted methodology. We are adopting an iterative approach. We're starting from initial review that we have presented now, and we gathered the system requirement and specification. We did an initial UML modeling, use cases, activity, and block diagrams. We developed the IoT cloud-based internet theft and anti-theft vehicle framework, and we developed the hardware, and we didn't develop it, we deployed a hardware and software prototype. We did initial testing. We took some of the results and lessons, and we are in the second iteration now. We are doing more testing and validation. So we will move the overall view of the smart anti-theft system framework. As you can see, we have the cloud computing, and we have the sensors and edge devices, which we, in our case, the IoT layer here, and in between the fog computing. What happens here is what we are investigating. What happens here is what we are investigating. How effective of the fog computing to be in the middle between the IoT and the cloud computing. We are having the network and connections layers, which is the fog nodes. We have in the cloud computing, we use it for the storage and access layer. And what in the fog computing is the processing and interpretation layer, application layer, and end users. The IoT layers incorporate like the IoT sensors. We have the GPS, multi-camera, and the devices, the switches, and we have a SIM card, a local storage, and we have the anti-theft, the brake systems here. Mainly, after we developed the framework, we did a system design. What are the functions that we need to implement? Currently, we are implementing these functions, and we haven't done this part yet. So the login as an authorization between the owner and the vehicles through the satellite and the cloud center and the whole system. We did some tracking. We contact the owner through SMS. We get the vehicle information. We did the implementation of these top use cases. We are currently working on the stopping the vehicle, storing, updating the information, and use the camera for face recognition system. As you can see, the activity diagram is a basic, we cannot say, it's a basic UML activity diagram. We start here, login, after it's authorized. The vehicle control, we can control the vehicle, permanent lock, fuel cut, electricity power off. We can get the user the vehicle information, GPS location, trips history, and vehicle information. Contact the owner, send SMS, make a call, and owner information. All these activities is connected to the cloud through fog nodes. What we are going to do in the future is to use the camera to take a picture and record the video. Once we record the video or take a picture, we can analyze the data. We can have a face recognition system and find a match in link with the police station and send the result to the owner and to the police. This is a short representation of the system functionality. Here is the UML block diagram. We will have the microcontroller, and we have linked the camera and the GPS model and the GSM model and the local memory and the power supply to the microcontroller, injection fuel, and this is the triggering driver, which is the 4-channel. Here is the initial result. We developed a web-based application for Internet of Cloud-based vehicle anti-theft system, and we will develop a mobile application. We did we did a tracking of a vehicle from one location to another location, and there is a SMS messages sent to the owner. What we are going to do next is to embed a face recognition system to acquire an image, and we will extract the feature, search for a match within the face image set, and then if we find the match, we will send it to the owner or to the police station. I'm afraid I don't have too much time, but I will summarize the hope or the initial result of this study. There are limitations of IoT devices. Is there limited storage capacity and processing power? So if an IoT device take a picture or something, it doesn't have the capability to store it or to process this image. What we need here is, alongside with the IoT device, is to have a processing power and massive storage capacity, which can be provided by cloud computing. Cloud computing can help us, can improve the performance, can improve the storage capability, and can extend the processing capability, and can be cost effective. But the cloud have some limitations. The big limitation is high latency, and there is downtime, and the security and privacy always will be a problem in the three technologies, the Internet of Things and fog and the cloud. But if we introduce the fog computing approach, we will have low latency due to its close geographical distance to users. We will have fewer bandwidth issue. We will have less connection loss. We will have a higher security. We will have a power efficiency due to a small amount of electricity used to power edge devices. But what fog computing have as an issue is the formation of complicated system. How do we put many edge nodes and link them together? It will be an extra cost, like in terms of the hardware, and the scalability limitation when compared with cloud scalability. The shortcoming of fog computing can be solved economically, like by the extra cost for the hardware, and the cloud as a scalable storage. I believe that if we integrate the three technologies, we will have a powerful anti-theft tracking system or solution. The future work we will do an extending the functionality of the system, the integration of other IoT devices. We will add more devices and test them. Implementing the embedded face recognition function via the use of appropriate artificial intelligence algorithms and computer vision libraries. We will do an investigation, the response time of the proposed system, as well as investigate further communication methods between the proposed system and the owner instead of smart messaging system or small messages. Performing more testing and validation to prove the advantages of fog computing approach when compared to cloud computing alongside with the Internet of Things devices. This is our current research. We are working on that, and this is a list of all references that we have reviewed recently. This is a young research. We don't have fund yet, and we are looking forward to for the fund, and we will see how we can go there from this point. And thank you for your time and listening to our humble work.
Thank you, Dr. Isa, for your informative presentation. Thank you for keeping the time as well.
Yes.
So to the audience, if anyone has a question for Dr. Isa, you can write your question or you can speak out.
Where this system is mostly followed, in which country?
Oh,
it is in Saudi Arabia, specifically at Hayel University.
Thank you.
Okay.
Most welcome.
Any other question? Okay. Thank you, Dr. Isa, again. We'll move on to the next speaker.
Thank you very much, Dr. Rabi', for the opportunity, and
you're most welcome.
All of our attendees.
You are most welcome. Thank you so much. We'll move on to the next speaker, Dr. Munawar Khachout. He is associated with the University of Hayel, College of Computer Science and Engineering. He will be presenting his work on deep learning with neural networks. So the mic is yours, Dr. Munawar. You can unmute yourself. Yes.
Thank you, Dr. Rabi'. Do you hear me?
Yes, I can hear you now.
Okay.
You can share your presentation.
Okay. Okay. You see my presentation now?
Yeah. Yes, I can see it. Thank you.
Okay. Okay. So hello and welcome. My name is Munawar Khachout. I'm assistant professor at University of Hayel. And I'm working now in cybersecurity domain using artificial intelligence techniques and deep learning algorithm. Thank you for this opportunity In this presentation, I will deal with deep learning with neural network. Now, there are several applications of deep learning, really very interesting and innovative. One of them is identifying geographic location based on picture. How this works, we train an artificial neural network with 1 million of images which are tagged their location. And then when we feed a new pictures, it will be able to identify the geographic location of the new images. For example, you have all these images, especially, but maybe some significant monuments are all significant location, and you train the million of such images. And then when you feed another images, it need to be exactly one of those that, but if you have claimed, it can be completely different. That is the whole idea of training. It will be able to recognize, for example, that is the picture from Paris. Because it's able to recognize the Eiffel Tower. So the way it works. Internally, if you have to look a little bit under the hood, yes, this image are nothing but is digital information in form of pixel. So each image could be a certain size. It can be doing 6 by 256 pixels kind of resolution. And then each pixel is either having a certain grade of color, and all that is fed into the neural network, and it then gets trained, and it's able to base it on the pixel by pixel information. It's able to get trained and able to recognize the future and extract the futures, and thereby it's able to identify these images and location of these images. So what we are going to do in this presentation, we will see what is deep learning and what do you need for deep learning. One of the main components of, sorry. Component of deep learning is neural network. So we will see what is neural network, that is a perceptron, and how to implement logical gate like OR, and NOR, and so on, using perceptron. And also we will see the different type of neural network and their applications. So let's get started. What is deep learning? Deep learning is like a subset of what is known a high concept called artificial intelligence. So artificial intelligence is like the high level concept. If you will, and in order to implement artificial intelligence application, we use what is known machine learning. And with machine learning, a subset of machine learning is deep learning. Machine learning is a little bit more generic concept, and deep learning is one type of machine learning. We will see a little later, in the following slides in more detail how deep learning is different from traditional machine learning. But to start with, we can mention that here that deep learning uses one of the differentiation between deep learning and the traditional machine learning. Is that deep learning uses neural network, and we will talk about what are neural network and how we can implement. Little deeper in to deep learning. Deep learning primarily involve working with complicated unstructured data compared to traditional machine learning. Here we normally use structured data in deep learning. The data would be primarily images or maybe text file. And it is a large amount of data as well. And deep learning can handle complex operation. It involves complex operation, and other difference between traditional machine learning and deep learning is that the feature extraction happens pretty much automatically. In traditional machine learning, features engineering is done manually. The data scientists have to do feature engineering, feature and extraction. But in deep learning, that happens automatically. And of course, deep learning for large amount of data, complicated unstructured data, deep learning gives a very good performance. Now, as I mentioned, one of the secret sources of deep learning is neural network. Let's see what is neural network is. A neural network is based on our biological neuron. The whole concept of deep learning and an artificial intelligence is based on a human brain. And the human brain consists of billions of tiny stuff called neuron. And this is how a biological neuron looks. And this is how an artificial neuron look. Neural network is like a simulation of our human brain. Human brain has a billion of biological neuron, and we are trying to simulate the human brain using artificial neuron. This how a biological neuron look. It has 10 drive, and the corresponding component with an artificial neural network is an artificial neuron, and are the input they receive, the input through dendrites. And then there is the cell nucleus, which is basically the processing unit in a way. So an artificial neuron also, there is a pieces which is an equivalent of this cell nucleus. Based on the weight and biases, we will see what exactly weight and biases are as we move the input get processed, and that results in an output. And in a biological neuron, the output is sent through the synapse. In an artificial neuron, there is an equivalent of that in the form of an output, and biological neuron are also interconnected. So there are a billion of neurons which are interconnected. In the same way, artificial neurons are also interconnected to this also interconnected. So this output of this neuron will be fed as an output to another, so on and so on. Now, a neural network, one of the very basic units is a perceptron. So what is a perceptron? A perceptron can be considered as one of the fundamental units of a neural network. It can consist at least one neuron, but sometimes it can more than one. But you can create a perceptron with a single neuron, and it can be used to perform certain function. It can be used as a basic binary classifier. It can be trained to do some basic binary classification, and this is how a basic perceptron look. It can look, and this is nothing but a neuron. You have in input x1, x2, xn, and there is a summation function, and there is what is known an activation function based on this input, what is known the weighted sum. The activation function either gives an output like 0 or 1. So we say the neuron is either activated or not. So that is the way it works. So you get the input. These input are each of the input are multiplied by the weight, and there is a bias that gets added to that whole thing is fed to an activation function, and then that results in an output. And if the output is correct, it accepted. If it's wrong, is an error, and then that error is fed back to the neuron, then adjust the weight and biases to give new output. This is a concept called perceptron learning. Perceptron learning, so is again one of very basic learning process. So the way it works, it's somewhat like this. So you have all these inputs, x1, xn, and each of these input is multiplied by weight, weight, and that sum. And that sum, this is the formula of equation. So sum wi xi sigma of that, which is a sum of all this product of x, y plus b. And the summation of course, and the summation of course passed through the activation function, as you see here. And based on that, there will be an output. That output is compared with the actual or accepted value, which is also known as labeled in information. So this is a process of supervised learning. So the output is already known, and that is compared, and thereby we know if there is an error or not. And if there is an error, there be there it's feedback, and the weight and biases are updated accordingly till the error is reduced to the minimum. So this iterative process is known as a perceptron learning. The whole process is iterative process, and this is the A creation continue until either the error is 0 which is in likely situation, or that is the minimum possible within this different condition. In 1943, two scientists, Warren and Wetterbeds, came up with an experiment where they were able to implement logical function like OR and NOR using neuron, and that was a significant breakthrough in the science. So they were able to come up with these most common logical gates. They were able to implement some of the most common logical gate, which could take two input like A and B, and then gives corresponding results. For example, in case of NAND gate, A and B as input, and then the output is AB. In case of an OR gate, the output is A plus B, and so on and so forth. And we are able to do this using single layer perceptron. I will give you example for implementing AND gate. Now, so most of these cases, it was possible to use single layer perceptron for XOR, and we will see what is in a little bit. So this is how an AND gate work. The input A and B, the output should be fired, or neuron should be fired only when both input are 1. So how do we implement this with a neural network? So it was found that by changing the value of the weight, it is possible to achieve this logic. So for example, if we have equal weight like 0.7, 0.7 here and here, if we take the sum of the weighted product, so for example, 0.7 into 0 and then 0.7 into 0 will give 0. So the output is 0. But when the A equal to 1 and B equal to 1, the weight 0.5 and 0.5, the result is more than 1, and 1 is the threshold. Then the output is open, and it will get 1. This is an example for an AND gate. I don't have much time, so for this I will go to type of a neural network. As we can see in this slide, type of a neural network. Neural network is nothing but there are different types of neural network. There are about 5 of them. There are artificial network, neural network, convolutional neural network, recursive neural network, or recurrent neural network, deep neural network, and deep belief network. So in each of these type of neural network have a special, they can solve special problems. For example, convolutional neural network are very good at performing image processing and image recognition, and so on. Whereas RNN are very good for speech recognition and also text analysis, and so on. So each type has some special characteristic, and they can do good performing certain special kind of task. some of application of deep learning. Deep learning today is used in gaming. Maybe you know, we heard about AlphaGo, which is a game created by a startup called DeepMind, which got acquired by Google. And AlphaGo is an artificial intelligence which defeated the human voice champion list at all this game of AlphaGo. So gaming is an area where deep learning is being extensively used, and a lot of research happens in the area of gaming as well. In addition, to that nowadays there are a neural network or special type called generative network, which can be used to synthesize for synthesizing either images or music or text and so on. And they can be used to compose music. So the neural network can be trained to compose certain kind of music. Another application, autonomous cars, they must be familiar with Google's self-driving car, and today a lot of automotive companies are investigating in the space, and deep learning is a core component of these autonomous cars. The cars are trained to recognize, for example, the road, the line marking on the road signals, any objects that are in front, any abstraction, and so on and so forth. So all this involves deep learning. Another major application in robot, we have seen several robots, including so far you may be familiar with Sophia. Sophia, who was given a citizenship by Arabia Saudi, and there are several examples such robots, which is very human-like, and the underlying technology in many of these robots is deep learning. Medical diagnostic and healthcare is another major area of deep learning. It's being used, and within healthcare diagnostic, again, there are multiple areas where deep learning and images recognition, images processing can be used, for example, for cancer detection. As you maybe, if a cancer is detected early, on it can be cured, and one of the challenges is in the availability of specialists who can diagnose cancer using these diagnostic images and various scan and so on and so forth. So the idea is to train neural network to perform some of this activity, so that the load on the cancer specialist, doctor, or on challenges come down, and there is a lot of research happening there, and there are already quite a few applications that are claimed to be performing better than human beings. In this space can be lung cancer, it couldn't be breast cancer, and so on and so forth. So healthcare is a major area also where deep learning is being applied. So we have come to the end of this presentation, and thank you very much for going through this presentation. I hope this was helpful. Thank you.
Thank you very much, Dr. Munawar. Thank you very much for your knowledge sharing. Anybody has any questions, please ask. If you have any questions, please ask.
Thank you very much, sir, for his great description. I want to ask that deep learning actually only related to robotics?
Yes, deep learning related to robotics, but also in other many applications. I was explaining this in healthcare, in image processing, in self-car driving, and in many other applications.
Well, thank you.
Thank you.
Anybody else has any question or query?
Dr. Munawar.
Hello, Dr. Isa.
Thank you for the presentation. It was a really good experience, learning experience, especially for me. My question is, how is your work related to what is called explainable deep neural networks?
Okay, actually, I am working in cybersecurity domain. I was shared this presentation just for shared my knowledge with you, but I'm using deep learning in cybersecurity to detect cyber attacks, and maybe at the university we can talk deeper in these techniques. Okay,
yes,
Dr. Isa?
Sure. Thanks a lot, Doctor.
Thank you. Thank you.
Thanks.
Okay. Anybody else has any question? Thank you, Dr. Munawar. Thank you very much.
Thank you, Dr. So, thank you.
Okay. Thank you, Dr. Isa. Okay. Now I would like to invite Dr. Zainab and Dr. Gursel from University of Toledo. Dr. Zainab and Dr. Gursel are going to discuss on their work on UNSW NB15 computer security data set analysis through visualization. Dr. Zainab. Dr. Zainab.
Hello. Hi. Thank you in advance for providing us with this opportunity to present our research in front of dear audiences. Actually, I think I have to fix this problem. I'm the master student at the University of Toledo. So it's good for me to have a doctor's name before my name, actually, but
I'm so sorry. Let me repeat it again. Dr. Gursel and Dr. Zainab. I would like to invite
Dr. Gursel Serpin and Zainab Zoghi, I think.
Zainab Zoghi.
Right. So I think I have to share my screen.
Yeah, you have to screen.
Yeah. So can you see my screen right now?
Yes. Yes.
All right.
The screen is visible.
All right. Okay. So yes, I'm Zainab from the University of Toledo. I'm working with Dr. Serpin, my dear advisor, and also the chair of electrical engineering and computer science department at the University of Toledo. Special thanks to him for supporting me within this research, and also special thanks to my parents for giving me positive energy and pushing me forward. Actually, in this research, we analyze UNSW-NB in terms of two major issues in data mining, which means data overlap and data imbalance. So we hypothesize that UNSW-NB suffers from these two issues. That's why we visualize the issues using a variety of models. But before going into detail about these methods, I will discuss the reason behind choosing UNSW-NB to evaluate my model. So UNSW-MB15 is one of the popular and open access data set in cybersecurity area. It had been released in 2015, consisting of roughly 2 million records. So it means that this data set is the new data set, and also it has, I would say, enough records to train the model or machine learning model, I would say. So it also contains the realistic and modern normal and abnormal records or network activities, and also it is more complex in comparison with other cybersecurity data sets like KDD-COP99. So because the goal of this research was to design the machine learning model to keep the intruders away from the network, which I would say designing the intrusion detection system. If our model works appropriately and gives us a good or reasonable output on the data set with these features, so it means that the reliability of our model will or have been verified. So this table shows kind of a detailed information about the UNSW-MB15. We can see that we have 10 classes in this data set, normal records, as well as 9 other attack classes. So this data set originally split into training subset and testing subset with this number of records, corresponding to each attack classes or normal records. I will refer to this table in the near future. So just for information, I just wanted to introduce you to the UNSW-MB. So we said that, or we actually hypothesized that UNSW-MB15 suffers from class imbalance and class overlap. So finding or proving or supporting our hypothesis, I would say, is important, because if this data set suffers from these two issues, we can find the methods, the pre-processing methods, before applying any machine learning model, which helps our machine learning model to find the output in the best way, and do not confuse with a real bad data set. So we have two class imbalance type between class and within class imbalance. So between class imbalance is the case when we have one class or multiple classes with the significantly unequal data point distribution. On the other hand, within class imbalance is the case when we have only one class, but this class split into several subclasses, and again with significantly unequal distribution between these subclasses. Also, the overlap issue is the case when we have different classes, but each class mimic the behavior of another class. So because we're working on cybersecurity, and because we have to minimize the actually false negative rate, we're just focusing on the attack classes, mimicking the behavior of the normal workers, or mimicking the normal behavior. So again, we need to train our model with the data set that address these two issues before applying any machine learning algorithm. So the first and the easiest, I think, way or method that we utilize is column chart. So this chart, as well as this table, shows us that our data set suffers from between class imbalance. So for example, about the worms, we have overall 174 records here, while we have 93,000 records of normal class. So it shows the clear between class imbalance. Also, in terms of the percentage, we can see that 0.01% of the overall data set is in worms class type, and 87% of overall data points are normal class. So again, this method shows us that our data set suffers from between class imbalance. Also, about the within class imbalance, we utilize 3D scatter plot. So to show the within class imbalance, we couldn't keep all the classes in one plot. So we kept only one class, and we analyzed one class, and we found that we have two concepts here: class concept and class subconcept. So class concept consists of the higher data point distribution, and class subconcept consists of the lower data point distribution. So we can see that we have different subclasses of exploit, and also in next slide we display worm class. Because worm class is the minority class, we wanted to show that even in the classes with the less data points, we can see the within class imbalance. In the next slide, because we wanted to have all the classes, class types together, we wanted to show the data points all together, we found that it's a good idea to use TSNE, or T-distributed stochastic neighbor embedding. So this method actually is used to visualize high dimensional data set. So because we have 42 variables in UNIS WMB, we found that this method, TSNE, is a good method to visualize our data set, and found if our data set suffers from between class imbalance. Also, we found that combining TSNE with PCA will help us to visualize our data set more clearly. So we combine these two methods, and we can see easily that we have several subclasses of normal class in different areas on this plot. And also, I mean, because we just analyzed normal and shellcode, because normal was a majority class and shellcode was one of the minority classes. So also in the minority classes, we can see the between class imbalance. About the overlap issue, we again use 3D scatter plot, but at this time we kept all the classes together. In some cases, like in some areas in this plot, we can see that, okay, for example, normal record can easily separable, but in some other cases, like these highlighted areas, we can see that there is the overlap problem. So to dig into this problem, we zoom in the 3D scatter plot, and we found, and we only kept the exploited normal, because we it is so important to analyze the attack classes if they mimic the normal classes. We wanted, as I said, we wanted to minimize the false negative rate. So it's good to analyze the attack classes and compare it to the normal classes if they mimic the normal behavior. So in these two areas, we can see some subclasses, but in this area, we can see that this subclass has the high overlap probability, because it seems that the data points are mixing together, and it seems so hard to separate the data points in this area. But in this area, we can see that, okay, so we have exploits and normal data points together in this area, but it seems that the exploit data points is on the top of the normal data points. So it seems that it has the lower overlap probability. Also, in the next slide, we can see that the fuzzer class mimic the behavior of the normal records, and it seems like it suffers from the high overlap probability in this area and also in this area. So we finally use k-mean clustering and intercluster distance to map the overlap issue. So k-mean clustering used to cluster or do the clustering or do the classification, kind of a classification, our data set into 10 different classes or clusters. And also k-mean clustering finds the centers of each clusters. So having this value, intercluster distance, find the distance between two centers, and then it maps the areas that the clusters are here. So the size of each circle represent the distribution of a data point in each cluster. So for example, in cluster 4, we have thousands of data points, while in cluster 7, number 7, we have small number of records. And analyzing this map, we can find that yes, we have some part of our map overlapping each other. So this part shows the overlapping problem in this data set. So to wrap it up, actually we hypothesize that our data set suffer from 2 major issues, namely class imbalance and class overlap. This visual, to find actually, or to support our hypothesis, we visualize these 2 issues, and this I think phase or step is so important, because finding finding if our data set suffers from these issues, and finding if or how much serious these problems are, can help us to find what pre-processing method we have to use before applying machine learning algorithms on this data set. And thank you all for putting your time on my presentation and listening to my presentation. If there is any question, please feel free to ask.
Any questions, please? Anybody has any query? Thank you very much, Dr. Zainab.
Thank you too.
Now, I would like to invite Dr. Ehtreem Raza Khan from Department of Computer Science, Jamia Hamdard University. Dr. Khan is going to discuss his work on software engineering from start to the present, how successful we have been, and the road ahead. Over to you, Dr. Khan. Dr. Hitram. Hello.
Hello, am I audible, ma'am?
Yeah, you are. Thank you very much.
Yeah,
Please start.
very good afternoon. Assalamu alaikum, everyone. Hello, assalamu alaikum, everyone. Can everyone hear me?
Yes, we can.
Yeah, so I'm sharing my screen. I was just testing my system. Actually, it was not working. It's started now, finally, thank God. Yeah. Yeah. I'm sharing my screen, ma'am.
Okay.
Just a moment, just a moment. Is my screen appearing now?
Yeah, it is visible.
Yeah.
Thank you very much.
Yeah, so thank you for giving that extra time. I was just struggling with my sound system. Now I suppose everyone can hear me. So I'm starting the presentation and I'll be keeping it very simple. I'm going to give one case study also about the work about cost estimation. And before that, I'll be talking theoretically on software engineering, and we'll see from where we have started and where we are right now. So if you can see on the screen, the talk is from the start to the present, how successful have we been and the road ahead. I'm Dr. Hitram Raza Khan. I represent Jamia Hamdard, Delhi. It's one of the Center of Eminence awarded by MHRD, Government of India. Special thanks to NCSCT team for giving me a chance, Dr. Rabi Ramadan, Dr. Kusum Yadav, Dr. Ahmed Alangar, for giving a chance to speak on this platform. So if you see the screen right now, there's a very favorite quote: software engineers have the power to create great solutions, but the best software to solve the least important problem is of no use. So as long as we are developing softwares for wonderful problems, that is good enough. So if you look at the screen, you please go through the screen. I'll just read it out and then I'll pick it up. The journey of software engineering has been a long one. It started with the word software crisis, the word in red, which was a term used when softwares continuously failed and were unproductive and missed the schedules. The computer languages that were used during that period of time were Algol, COBOL, Fortran, Pascal. Actually, we were developing monolithic softwares, one big software, one big program of software. That was monolithic software. We'll be talking more on that. If you look at the last line, the NATO Science Committee sponsored 2 conferences in which the software engineering term was coined. So what software engineering actually is, software engineering is concerned with theories, methods, and tools which are needed to develop a high quality complex software in a cost effective way. But the last line is important: on a predictable schedule. You have to be on time. So this screen is important from the discussion that we will have today. The journey of our programming languages, if you can see, C came in 1972, C++ 1983, Python 89, Visual Basic 1991, JavaScript 1995, C# 2000, and VB.NET 2001. So we started our journey in such a manner. Softwares have always been developed. If you look at the second one, from the monolithic software We have moved towards the modular systems. We are not talking about structured system. As soon as we had C, we started developing functions. Functions, small programs, and a software is a collection of small programs. So from the TPS, we moved towards management information system, and from there we moved to decision support systems. Then came the ERP, and the intelligent knowledge-based systems have become the next buzzword, and the front end, the back end tools that keep changing as the time progresses. And we moved from centralized to distributed systems. Right now we have all distributed systems that we work on. So our journey began with monolithic software. One big problem was difficult to code. It's very difficult to write one big program of 1,000 lines, 2,000 lines, 3,000 lines, and equally difficult to debug it if something went wrong. So testing was even more difficult for that monolithic software. The same was true for maintenance. Then modular systems came up with C, C++ and all, with reusability and all. The modular systems came into existence, and modular system eliminated these problems, and we started getting quality software products. When we say quality, quality in terms of correctness, reliability, performance, usability, maintainability, reusability, and portability. Take your software to any system in the world and it will work. Reusable, you make software once and then you can use it multiple times. So when we started with this software started getting delivered, we came out successful. The initial model we talked about was waterfall model. We all are familiar with this model. Somewhere down the line, we have worked on this waterfall model. And in green rectangle, you will find there's a term written, there's a line written, plan out everything. So the problem with waterfall model was you have to plan out everything. All the requirements have to be frozen. The requirements from the users, from the clients, from the stockholders have to come up first. And then you start working on the system. So this is how the waterfall model would look like. You had requirements, you collect the requirements, you design the system, you implement it, and then you deploy or maintain the system. This kind of development would take a long time, and what would happen if the same product has been released by someone else? Now, this is the very real problem, realistic problem that the market faced. By the time your software was ready for release, and when it came into the market, you found out that some other product has already conquered, invaded the market. So, and the entire software failed in that way. We were not able to get the profits that we had planned. So if you look at the last line, expectations are never the same as reality. So we should change our plan number one, which was to plan everything in advance. We'll have to change that. So if you look at the second one, this is the current scenario that we have been working on. And out of 73 or 75 people who are attending the session right now, everyone must have heard the term agile. So if you look at the agile computing, agile methodology, now look at the second rectangle, which says strategy number 2, and the strategy is still plan, keep on planning, but with a constant change in mind. But do keep in mind that we'll have to change also. So the requirements are not frozen here. We will change. I'll take examples and give you the real life examples right now where we are using this, and then you will. And there were 17 wise men who sat together and came up with a new concept called agile. So for being agile, we have to look at these steps. Number one, to do things little by little. We have to do things in chunks, small chunks. I'll tell you how in the next slides. Accept the change, and then these chunks are released to the users. These chunks are then shown to the stakeholders, to the clients. This is a chunk that we are working on. The client will, or the user will tell you the changes that I don't want this in my software or in my chunk of software. Please change this. So the second point says accept the change. So do something, do the things little by little, accept the change, whatever the clients and the stakeholders are telling you, accept those changes. Third, evaluate constantly, keep on evaluating. Now, according to the market constraints, according to the market scenario, according to your clients, keep evaluating and keep adapting. Now, the fourth word is important, adapt, and then make the proposed changes. So somehow this cycle will take about 2 weeks time, and in 2 weeks time, your software again goes for an update. So I'll take some examples in the coming slides. Now, this slide is important. Please go through this yourself also once I read through it. So agile technology has touched all of us. Amazon, Netflix, Facebook, Google, Adobe, and many more in the industry. They're all touching this technology. Have you ever imagined that you were looking at some films on the Netflix and then on Hotstar and all, you're watching, and then some changes in Netflix will be propagated to the Hotstar also, to the Prime also. So they are propagated because you get the feedback that your competitor company is doing this and this. So why not update our own software also? So we keep on changing. These companies are keeping on changing. Amazon has been the best example, Netflix, Facebook, Google, Adobe. Now, second, if you read it, being agile means, again, the revision for last slide, release the software in chunks, in small parts, not the entire software. The entire software will take 6 months or a year. So release the software in chunks, in smaller parts. This is a scenario that we are looking after these days. Get the feedback from the stakeholders, talk to the stakeholders, get the feedback, whatever they are saying, take their advices, and re-released according to the customer satisfaction. So if you look at the last one, re-released according to customer satisfaction. And if the customer is satisfied, if your stakeholders are satisfied, there's no reason in the world why your software will fail, why your software will need revision once it is into the market. So this cycle goes on and our work becomes easier and becomes satisfactory also. Now, something in red paragraph again would give you some examples. Instagram was initially a location tracking application, but getting the feedback that Insta had, people were more interested in pictures and videos and all, they adapted and they made Instagram what kind of application it is right now. It is no longer a location tracking application. YouTube was a dating application. Believe me, it was a dating application. And then later, once they got the feedback, then they changed it according to the feedback. That the customers are more important, the clients, the users are more interested in videos and that stuff. So Twitter was a music sharing application, but they released later with a different purpose, with a messaging utility. So this is a benefit of using the agile methodology that I have been discussing. So initially we started with something like waterfall or iterative enhancement and all, but then right now we are totally working with agile methodology. There are lots and lots of research options available with agile computing. I'll discuss on my slides what are the research areas that we can focus on in the coming times in software engineering. Because for last yesterday also and today also I've been listening. I have been in fact listening to all the speakers, all the keynote speakers. We have been talking about AI, we have been talking about big data, we have been talking about IoT, we have been, so all applications that are being made, been developed in this, but somewhere down the line software engineering is behind it, because you'll have to go for the engineering part. The economics comes in, they all will come under software engineering. So the benefit of being agile would be productivity would increase, quality would be there, customer service and satisfaction would be maximum. So this is the kind of scenario that we have been dealing with, how to do it the agile way, break a project into 2-week iterations, as I told you. There is a Scrum team, the agile team, which will work together to achieve a goal. They will keep a 2-week delivery, like they will meet after 2 weeks with a delivery. The Scrum coach or the Scrum master will monitor the progress. There is a CR of this team. The team will meet for 15 minutes daily and then will discuss, will meet, discuss and adapt to the feedbacks that they have been getting. After 2 weeks, take the feedback from the product owners or the stakeholders and continuous delivery and customer satisfaction. This comes under a very important domain, as you have been seeing, that is continuous delivery and continuous iteration. That is a concept that has been going on. Lots and lots of research is going on into this. So I discussed that also. So as the technology is moving at a very fast pace, we'll have to adapt for larger projects. For larger projects, we'll have to somewhere adapt to the markets and to the stakeholders and whatever feedback they given. So agile would be A, adapt, advance to the next level. G would be groom the requirements, learn from the requirements, learn more and more from the requirements that you have. I would be iterate the project. That is, keep modifying the chunks, the smaller part of the software that you're talking about. L would be launching it, learn and launch from the experiences. And E would be the empowered team, the flexible team. So this team is very flexible. They have been doing whatever the changes, like you see something on the Netflix and very soon you'll see the same thing in Hotstar or in the Prime videos and all. You'll find the changes very quickly, or same holds with the mobiles also. You find some features in a mobile and the very next 2 days, 3 days, you'll find some other mobile carrying the same feature. So that is again looking after agile technology. So before I take you to another slide with a 1 minute break, so that I can take you to one of the case study of software engineering, where I'll use effort estimation, COCOMO model. You all must have gone through COCOMO model and how neural nets are helping in estimation of the cost. But before taking you into that detail, because I saw everyone was presenting some work or the other, I thought I look to be very theoretical. So why not I should also take something that I have been working on in my expertise. So if you look at the topics for research in software engineering, it's a wonderful field, software engineering, but people right now are going into mining, into artificial intelligence, into IoTs and into different analytics and all. But I would say if you go for software engineering again is a wonderful stream, is a wonderful balance of things. If you look at these 6 softwares on the screen, these are one of the research areas, very important research areas where the research is going on. We have candidates with us who are working on this hybrid between software engineering and artificial intelligence with sustainability. Now we are talking about sustainability. We're talking about sustainable goals, to achieve sustainable goals, to less carbon emission, less electricity consumption and all, cleaner cities. So we are talking about sustainability. So there has to be a hybrid between software engineering and AI along with sustainability, then a hybrid with software engineering and AI, software engineering, data analytics, software quality engineering. There is every other person, every other company is asking you to evaluate the quality. So once you have the quality have to be measured. So you must have heard the term metrics in software engineering. Metrics means measurement. So there are lots and lots of research going on in software quality engineering, then effects of agile teams on productivity, impact of team homogeneity on software quality. So these are the some. Then other fields also are there, which I'll pass on the slides to the coordinator. You can always have the slides from there. So these are the kinds of research areas that are there in software engineering, easy research areas where you can devote your time. If you look at the last 2 or 3 lines, these research are very important right now. They're going on. Effort estimation of agile development using fuzzy logic, effort estimation using neuro-fuzzy logic, effort duration cost estimation in agile software development. So these are the kind of researches which are currently going on. So I'll go to another slide. So just give me a minute, please. Just a minute, please. Hello, am I audible? Hello, am I audible?
Yes, Dr. Khan.
Yeah, please, ma'am. I'll need 5 more minutes, ma'am. If the time permits, I'll need 5 or 10 minutes more, ma'am. I'll finish in time.
Sorry, sir, I'm not able to hear your voice.
Yeah, ma'am. I said I'll finish in time only, ma'am. Let me just take 10 more minutes, ma'am.
Okay. Okay, no issues.
Okay. So if you look, all can you see on my screen, the topic is, I have taken one of the case studies that I've been doing. This is one of my favorite research areas, to develop and analyze efficient algorithm for software estimation using neuro-fuzzy approach. So here, I'm trying to mix up neuro-fuzzy approach and I'm trying to take it into software engineering. I'm trying to estimate the effort, and from the effort, I would estimate the cost. And I will show that this approach that I've taken, neuro-fuzzy approach, has been efficient than the other approaches. So the aim was to integrate these approaches. I'm going to combine COCOMO. COCOMO, everyone must have done. Every one of you must have somewhere or the other time must have studied software engineering. So COCOMO is constructive cost model. It's one of the models which is used to calculate the cost of the software. The industry have been making use of this method. So I'm going to use this, and my research question would be, sorry, I just take you to the previous slide. Please go through these questions. Research question 1 was, can Mamdani NeuroFuzzy be integrated with COCOMO 2? What I'm trying to say is, can we use NeuroFuzzy and can we use it with COCOMO 2? Will the proposed model be efficient and accurate? Will I be able to get the efficiency that is required by the industry? And can Mamdani is the name of the scientist. So Mamdani and Tagasaki Suguno are the 2 models. So I'm choosing the Mamdani model. So you can search the internet, there are references there. You can always, I'll pass on the slides also. So can Mamdani based NeuroFuzzy system can be built in form of user-friendly GUI and be used along? Yes, finally you will see at the end of my slides, I have made a GUI for that. And based on that GUI, we have been able to achieve. Now this is the proposed methodology. Those who are comfortable with software engineering, those who have studied this COCOMO model, must be must have figured out in their minds that there are 22 parameters. There are 22 parameters which are estimating the cost. Now, if you look at the screen, there are 1, 2, 3, 4, 5 on the left-hand side.
I'm sorry to interrupt you, Dr. Khan,
yes,
but we are not able to see your slides.
Okay, ma'am. I'll just yeah, ma'am. I'm just. Just a moment. Just a moment, ma'am. Just got that. Is it visible now? Hello, is it visible?
Yeah, it is visible.
Yeah, I'm so sorry. I thought it is on. I'll just rush up quickly. So I'm talking about a software. I'm trying to integrate NeuroFuzzy and software cost estimation method COCOMO. So here are my questions that I'm trying to find out. Can I use NeuroFuzzy with COCOMO? Will it be efficient and accurate? And can Mamdani-based NeuroFuzzy system be built in form of a GUI? Mamdani is the name of the scientist. There are 2, Tagasaki Suguno and Mamdani. So I have used the Mamdani model. This Mamdani model, if you search on the internet, you will get a ready-made system. Now this ready-made system was used for integration with my system. This is the proposed methodology. If you look at the screen, and if you have studied COCOMO model, there are 22 factors, cost factors, which are there. And out of those 5 you find on the left-hand side and 17 you'll find on the right-hand side. And the input to this system, if you look at the screen, the input to the system is the size only, the size of the software. And finally, at the bottom of the screen, you will get the effort. So you'll just input into this neural net. We all know neural networks is a black box. You just give the inputs and you get the output. So here the inputs are the size, is the size of the software, and effort is the output that you are getting. And in between, what is happening is being done by the neural net, the weights, the classifiers, the weights and all being adjusted by the neural net. If you look at this, this is the cost equation that has been implemented in software. Effort is equal to the equation is given. So it will, my model will calculate the effort, and effort will finally calculate the cost. I'll take it to the diagrammatic form. Now this is the proposed algorithm that is there for this system. We'll fuzzify the data, then we'll defuzzify the data, and finally we'll get the cost estimated. If you look at, I'll just show you, this is the experimental setup. Now, if the conclusion part, this is my model, the third one is my model, which has the lowest MMRE, mean square root error. That is the minimum for this model. So there we found out that whatever concept we have taken, yes, we can incorporate neurofuzzy into COCOMO model. So this is how software engineering would go along. If you see the red line is the lowest effort being taken by my software to calculate the cost. So future is of this method is I can also use function points to calculate using the same method. So these were the references. I'll pass on the slides to you. So any question for me? Hello, am I audible?
Yes, you are.
It's been wonderful.
Anybody has any questions, please?
I have something to say for the audience, ma'am.
Yeah, please.
Yeah, I've been watching for 2 days. There have been wonderful questions from the participants, and there have been wonderful participation also. And one thing I have found, a very great difference I have found in the students in Middle East and all. The students have really picked up. They're really doing very well. Earlier, they used to come, some students used to come to our country. The English was very weak. But now I find there the English is also improving. Everything has improved. The students are doing wonderful. So that is something, it's a very pleasant surprise. And it really gives us lots of pleasure that you all are keeping those standards and you're all doing the kind of work that really makes us proud. So I was really lucky to be a part of your conference today. Really thank you, and thank you to our Dean sir also, Ramadan sir, Dr. Ramadan, Rabi Ramadan. I can see him on the screen. Thank you so much, sir.
Thank you so much.
Pleasure has been interacting with you.
Thank you so much, sir. With us. Thank you.
Yeah.
Thank you. Thank you. Thank you, ma'am.
Well, thank you. I think we can take 5 minutes break or something. Just grab a cup of coffee because we have, after the break, 5 minutes, we have wonderful topics from 2 keynote speakers will be with us, starting with Dr. Hazem after just the break at 1:40. Thank you all. Just grab anything to drink. Stay focused with us. Thank you so much.
Thank you.
مش عارف يعني مثلا. حاجة داخلية يعني.
Welcome back, everyone. After a very short break, Dr. Ala, the mic is yours, so please go ahead.
Yes.
Yes, please go ahead. We can see on the screen.
My desktop is clear?
Yes, it's clear, but it's just the presentation is not open. The slides is not open.
It's not open?
Yeah, the slides itself. We see the folder.
Now is it open?
No. Huh? No, can you reshare it? Stop sharing and share it again.
Okay. Is it clear now?
No, it's freezing. It's frozen.
Huh?
I see your mouse moving, so try to open. Are you opening the slides? Yes.
Okay.
Now it's open.
It's open?
Yeah, but thank you.
Okay, okay.
But
thank you for all and welcome back. Now we are going to the next presentation for one of our great keynote speaker, Professor Muhammad Hazem Kalaji. Professor Kalaji graduated in 1983 from Agricultural Faculty, Aleppo University, Syria. In 1993 at Warsaw University of Life Sciences, he received a PhD degree in agricultural sciences in the field of agronomy with the specialization of plant physiology. And later on, in 2013, he obtained Doctor of Science degree in agronomy. Both degrees were distinguished honor level by the Warsaw University of Life Sciences. In 1950, he got a position of extraordinary professor, and he is. Professor Kalaji belongs to a group of worldwide recognized specialists in the field of plant physiology, in particular in the field of photosynthesis of plants, photosynthetic apparatus in plants, and also plant assimilation apparatus, chlorophyll, fluorescence, and gas exchange, abiotic and biotic stressors, the creation of innovative solution for agriculture and environmental protection based on the combination of plant talk and machine learning is one of his interesting recent research ongoing. Professor Kalaji is a member of numerous international organizations, and he is distinguished speaker at numerous local and international conferences. He has achieved approximately 4,000 points considered by the Ministry of Science and Higher Education in Poland, and total impact factor of over 300 based on 176 publications, including 5 books, 23 book chapters, and according to Web of Knowledge database, his H-index is 28. Professor Kalaji reviewed several Polish and foreign doctoral dissertations over 700 national and international projects and over 100 scientific papers of international scientific journals. He is the editor-in-chief of some journal, and he is in editorial board of the several international journals. He was the most cited scientist in the field of chlorophyll fluorescence between 1912 and 1980. During 1913 to 1915, Kalaji was visiting professor at the NIT Institute of Coastal Zone Research, Chinese Academy of Sciences. He is vice chair of the Maria Sklodowska Korea Action at the European Commission in Brussels. And he's expert to evaluate Erasmus Mundus joint master degrees projects in the European Union, award of high quality logo of higher European universities. As part of international context, he has established cooperation with several dozens of institutions and universities worldwide. Dr. Hazim, thank you, and you are welcome, and we are glad to have you with us in this conference. Now you can share and go on. I will stop my sharing. Now, Dr. Hazim, Dr. Kalaji. Professor. Dr. Kalaji. Doctor, Professor Hazim.
Yes, he is on board, but he might have a problem in the mic or something.
What?
He is already logged in, so just a second.
Dr. Hazim, you can now you can get out and also enter the room another time to solve this technical problem. Dr. Rabia?
Yes, Doctor. I'm waiting on him. I'm trying to chat with him.
Yeah.
Okay. Just a second. Okay. He has a technical problem. So can we have, we can get, if he is already with us, we can get Dr. Sufyan if he is already in. I don't know. Let me check.
Okay.
Dr. Sufyan is not in yet. Okay. Just a second.
Mm-hmm.
Yeah, Dr. Sufyan is not yet in, and Dr. Hazim, he has a problem. So I believe, Dr. Ala, you can start your presentation.
Can I start my presentation?
Yes, please.
Okay.
We'll go in the other presentation until the keynote speakers are ready. So we'll move on.
Okay.
Yes, please.
Doctor, before I will share my presentation.
Yes. Yes, Doctor. Go ahead.
Dr. Hazim, send a message on chat, please.
Yeah. Yes. I'm following up. I'm following up.
You will plan. Can I go?
Yes, please. Go ahead. I'm following
Okay.
up with Dr. Hazim.
Okay. Okay. Is my presentation now is okay?
Yes, I can see. Yes. But there is some noise in the voice.
Here?
Yeah, from your mic, I believe so. There's some noise.
I think it is maybe the air conditioner.
Okay.
Okay. I will go on.
Yes, please.
Hello, everybody, and I am very glad to meet you in such event. And I'd like to thank the World Advanced Science for this support to complete and to go on with our conference. Now, I will take you in another field beyond the computer science and artificial intelligence. We are going to go to the field of biology, and especially in entomology. Entomology is the science of insects, of studying insects. This science is very, very great science because about 3/4 of the biomass on the earth is insects, are insects. These insects, we have about 1,400,000 species have been recognized and classified and identified. I am talking now about species. One of the most diverse diversity in the insects is the order Coleoptera. Coleoptera is the order of beetles. Beetles these beetles are a wide diversity, and now we will concentrate on one family of the order Coleoptera, the family Tenebrionidae, and one beetle in this family, which is Blapsculari. Mating behavior of the darkling beetle, Blapsculari, Coleoptera tenebrionidae. This is the contents. We will go on with the presentation, inshallah. Darkling beetle is a group of nocturnal insects. Their activity is not at the day. They are active in night, at night time, and they are inactive during the day. The darkling beetle are the members of the family Tenebrionary, including Flapsiculari. They are examples which have comparatively major role in tropical and subtropical dry lands. These beetles are important macro distributors, as they are considered primary decomposers. They are eating on the dead material, dead organic material. The mating or copulation duration is defined as a period of time spent by the male and female in sexual intercourse. Mating behavior is the only way here in the disexual organisms. It is one of the of the most important behaviors, because it is the only way to supply progeny. Successful mating depends on many factors. Firstly, the activity. Secondly, the fitness of both sexes, male and female. These promote mating for males and females. The mating in most insects, especially in our family and our insects, Flapsiculari, are composed of 3 phases. One is pre-copulatory, before intercourse, before sexual intercourse between the male and female. The other is copulatory. Then, after copulation ends, and after ejaculation and semen transfer occur, it will be another phase, which is post-copulatory guarding. Duration of mating, duration of this process of all phases is a very, very important item and a very important subject. Long duration of mating could be useful, the opportunity to fertilize the eggs. But on the other hand, mating costs